Okay, so today we are working on the next section of this unit, which is about multiplying and dividing rational expressions. It's actually probably the easiest one, so it kind of works out that I'm doing it this way. Where you're multiplying and dividing these things, there's a few rules you just need to remember, and other than that, again, learn them right the first time and then practice them, right? So rational expressions can be multiplied or divided, just like a normal fraction. Remember that when you are dividing by something, it's often easier to think about that as multiplying by its reciprocal. Again, just a quick example of that would be if you want to do like 5 divided by 4, it's the same thing as 5 times 1 over 4, right? So you like flip the denominator over and then make it multiplication. Obviously in this example it's kind of silly, but when you do it with rational expressions it can be really useful, right? Because you get something like, what we have down here, where it's division, and you can look at this one and just say, okay, well, rather than divide by some complicated thing, I'm going to just multiply by the reciprocal. So this one, it says simplify and state restrictions. So restrictions basically are going to have to come from the denominator equals 0. Okay, so that's going to be where your restriction is always going to be, because your denominator equals 0. So if we look at this first one, basically there are two possibilities for restrictions. 2b squared cannot be 0, and 9a squared cannot be 0. Now again, some algebra will show you that if you bring the 2 over to the other side and then square root, we arrive at the restriction a nor b cannot be 0. Okay, so that's just going to be your restriction for this first one. You're just looking at the denominator and you're saying what values of the denominator, what values of the variable produce a 0 in the denominator. Now, so your restrictions you can do at the beginning of these questions. I think that's probably a good idea. You just look at the question, you look at the denominator, you go, how could the denominator be 0? And you restrict all those values. When it actually comes to simplifying them, it's very, very simple to multiply fractions, right? To multiply fractions, it's just the top times the top over the bottom times the bottom. So it's that simple. So 1 over 2, right, times 1 over 3, or 3 over 4, let's say. You do the top times the top, which is 3, and the bottom times the bottom, which is 8, and you get, 1/2 times 3/4 is 3/8, and that's it. So multiplying is pretty simple. You're just making sure you follow that rule, and after we've stated some restrictions. So let's go ahead and try to do this one now that we know those basic rules, where we're just going to, write it out again. So 3a cubed over 2b squared times, multiply, 10b cubed over 9a squared. Now again, the top times the top is as simple as it looks like. 3 times 10, okay, let's make a fraction. So 3 times 10 is 30. Then I have a cubed, b cubed. A cubed cannot multiply by b cubed, right? Because they're different terms. So you just stick them together. On the bottom, you have 2 times 9, which makes 18, b squared, a squared. Now, when you go to finish one of these questions, it says simplify, right? So simplify means we got to look at the top and the bottom for common factors and clear them off. You can see here that, let's just copy this out again. I think this will let us do this. If we go here and we go to, I don't want to strike the whole thing. Just strike the, right? Strike that down to a 1. We'll strike this down to a 1, and this bottom part you can just strike all together, right? Because you're dividing both by a squared, b squared. Now, the 30 and the 18, you can divide them both by 6, right? So you end up with, a much, much simpler equation, which is, 30 divided by 6 gives me 5. 18 divided by 6 gives me 3. And the b squared, a squared is gone from the bottom. And from the top, we just have ab. That's all that's left, right? So this whole expression gets simplified down to 5ab. Now we're going to state our restrictions just to make sure. A not equal to 0. Oh, sorry. Like that. A not equal to 0. B not equal to 0. Okay, so you get basically that's your final answer. What your final answer looks like is right what I've written here in red. Okay, so once we've taken all the common factors and written them down. Okay, so let's go ahead and try a second one here. So again, when you're dividing, right? Remember that to divide by a fraction is to multiply by its reciprocal. So, you know, with this one, let's start and let's make an expression for its restrictions, right? So C is not allowed to be 0 because C is in the denominator. And then, you know, when I go to write this differently, so 2ab over 5c divided by, so I'm gonna change the divided to multiply. Okay, so I'm gonna multiply. I'm gonna put the 15c squared on the top and the 14a squared b squared on the bottom. And that did not do what I thought it would do. It's a squared b squared. Okay, so I've taken the question. All I did was take the second part, the part that's being divided, and flip it over. Now, when you do that, right, you realize that a squared cannot be 0. Oh, my goodness. A squared cannot be 0. And b squared cannot be 0, which of course we can write more simply as just a cannot be 0 and b cannot be 0. So here's a good example of one of those questions where it's like the restrictions are a little bit more complicated than just looking at the original question, because the original question you might not notice that a and b also cannot be 0. But if a and b are 0, right, then this second part of the equation is 0 and you can't divide by that. So you know, when you flip it over, it'll draw your attention to this, like C can't be 0 because the way the question's worded or written, and then A and B can't be 0 because they're in the denominator now, right? Once we flipped it over to do our multiplication. So again, just to be careful about that. To finish this question, you multiply the top, you get 30AB C squared. On the bottom, you get 70, right? 5 times 14 is 70. And then you get C, and let's put a squared b squared on the bottom. Okay, now once again, I am looking for common factors. I can divide the top and bottom by 10. I get 3 over 7. I can divide the top and bottom by a. That puts an a, you know, when a is left on the bottom. I can divide the top and bottom by b. Now b is just left on the bottom. I can divide the top and bottom by c, and c is left on the top, right? Because there are 2 c's on the top and only 1 c on the bottom. So your final answer is here. And again, we're going to write some restrictions. C is not 0, B is not 0, and A is not 0. Right? So those are the 3 restrictions that we have here. Again, this here is what your final answer ought to look like to be right here. Okay? So, you know, this basically that's it as far as like what is new today. What is going to be a bit different from here on out is we're going to be looking at ones where simplifying involves some factoring and some canceling and also doing this multiplying and dividing bit. So let's try to do one more here. So let's look at this one. We're doing x squared plus x minus 6 times this on the top. So again, let's just push D to its own page and we'll just look at this one. So we'll do x minus 3 over x minus 2. Oops. X minus 3 over x minus 2. Okay, so that's what we've got going on here so far. I'll make this a little bit bigger so it's a little easier to see. Okay, and now what we're got, so we're going to multiply, right? The top times the top. So the top is x squared plus x minus 6 times that x minus 3. And then the bottom is x squared plus 2x minus 15, and that's times the x minus 2. Now, when you get one of these questions where your options are to either FOIL and expand, in which case you're going to get a cubic. If you FOIL, you will get a cubic over a cubic, which you do not want. So don't FOIL, right? What we want to do here is we want to factor. If you factor this, let's look at that first thing. The first thing we have there, the x squared plus 6 plus 1. I need a sum of plus 1 and a product of negative 6. Those numbers are x plus 3 and x minus 2, right? And you see what's happening here. That minus 2 that I just came up with on the top is also here on the bottom, right? So there's going to be some canceling I can do here. So look at the bottom now. I need a sum of plus 2 and a product of negative 15. My numbers are plus 5 and negative 3. So we'll go x plus 5, right? And x minus 3. Now, when I look at it like this, it's like, yeah, the minus 2 and the minus 2 I can see are both things that I need to restrict. That I can cancel. Now, remember, what we're being asked to do here is simplify and state restrictions. So I need to restrict all the numbers that make the denominator 0. So, it's not that hard to do that. You write x cannot be negative 5, because that would make the first bracket 0. X cannot be 3, that would make the second bracket 0. X cannot be 2, okay, because that would make the third bracket 0. I'm not worried about what's on the top. I'm only worried about what's on the bottom. So you go here, okay, the x minus 3, you can strike that one. The x minus 3 here you can strike. And then the x minus 2 you can strike. And same with this x minus 2. So all of this can be canceled. And you end up with a very simple equation, which is just x plus 3 over x plus 5, right? Again, it might be worth just graphing this one just to show you how this kind of worked, but okay, so you end up with that. There's your final answer right here. I'll just put it in the blue again just so we have a different color. So again, what are we doing? We're multiplying. When we multiplied, we noticed there was a squared times a linear. Probably we don't want to be foiling that because you're going to make a cubic, and cubics are hard to factor. It's easier to factor if you just leave it the way it is. You factor the two quadratics, and then it turns out you have 3 factors on the top, 3 factors on the bottom, and a bunch of them cancel and disappear. Let's demonstrate this one quickly just visually so we could see. So we have x squared plus x minus 6. Okay, now we've got x squared plus 2x minus 15. Okay, we have f over g, so that's the first thing we're drawing. Then we have x minus 3 over x minus 2. Okay, and we're doing h times p. Now h times p actually looks a lot simpler than just h, right? Like look at just h. It has 2 asymptotes, a horizontal asymptote. It has like a weird local max in the middle. It's this weird like shape that we've never seen before. But when you multiply it by p, right, this other function, it gets an awful lot simpler. And if we just draw what we think the answer is, which is x plus 3 over x plus 5, x plus 3 over x plus 5, we notice that this very simple function is actually in every way the same as the complex function that we started with, right? Except, of course, at the restrictions that we already used. So, for instance, q of 2 is undefined, but r of 2, it thinks it's a number, right? So we got to make sure we restrict that. Of course, we already restricted that because in today's lesson, you're not just restricting what you're canceling, you're actually restricting everything that could make the denominator 0. It's a lot more similar to what we were doing with doing a domain. So it's simpler, just restrict at the beginning and just restrict everything. As you go through the questions, sometimes you'll get new restrictions that, you just need to watch for. But at the end of a question, you just collect everything you've restricted and make sure that it is in your answer. Okay, so there's a few left here and one word problem, which we'll do in the next segment.